We are working on 2.6a. So here is a factoring question kind of thrown in there. What do we call a quadratic that is something squared minus something squared? It's called a difference of perfect squares, and it factors into conjugates. So x minus 3 and x plus 3. What if I had x squared plus 81? How would that factor? So x plus 9, x minus 9, what do you guys think? Hopefully somebody disagrees. Should it be like that? Hopefully somebody disagrees. Why won't that work? When I multiply it out, I'll get x squared plus 9x plus 9x plus 81. And the 9x and the 9x do not cancel. So if I had a minus 9 and a plus 9, then that becomes negative. What if they were both negative? Then the 81 would be positive. So this actually does have imaginary roots. So difference of perfect squares. It has to be a subtraction. If it's not a subtraction, it won't work. Well, it won't work in the real number set. The answer is actually x minus 9i and x plus 9i. And when you multiply that out, you get x squared minus 9xi plus 9xi minus 81i squared. And then the 9xi's cancel. What is I squared? Well, I is the square root of negative 1. So I squared would just be I squared is negative 1. So that negative 1 right here makes that a positive. So make sure when you're factoring, if you have a difference of perfect squares, you can factor into conjugates. But if it's not a subtraction, it won't work. At least not over the real number set. All right. Okay. How do we graph this parabola? Well, if we could find the vertex, then it should be pretty easy to graph. And the vertex, the x-coordinate of the vertex, is always found at negative b over 2a. If that looks like it came from the quadratic formula, it's because it did. So in this case, a is 1, b is 10, and c is 21. So I just plug those into my vertex formula, and I get negative 10 over 2 times 1 is negative 5. That is the x portion of the vertex. So I have a parabola with a vertex somewhere on this graph, and I know that that point is negative 5 comma something. How do I figure out what that something is? Plug negative 5 into the equation. So we stick negative 5 in there, and we get 25 minus 50 plus 21. And that gives me negative 4. So the vertex is negative 5, negative 4, right there. And then we just follow the rules of parabolas. In this case, the leading coefficient is a 1, which means it's a regular shaped parabola. And I need to graph 5 points, so I go over 1, up 1, over 1, up 1, then over 2, up 4, and over 2, up 4. And then ask Alex to graph that by pushing the graph button. Everybody understand that? So the x portion of the vertex is always found at negative b divided by 2a. Okay, here they give you a parabola and they ask, does it open up or down? Well, that's hard. Find the axis of symmetry. That wants to know, what line can I draw to cut the parabola into two equal halves? What is the equation of that line? So x equals -1. How did you know it was an x equals equation instead of a y equals equation? Yeah. It hits the x-axis. So this graph hits every single point where the first part of the coordinate is a -1. So it hits -1, 3. It hits -1, 8. -1, 300 or 3000. So this graph is every point where x is -1. Okay. X-intercepts, just pull them off the graph, -4 and 2. The y-intercept is going to be negative, what is that? 8. And then the coordinates of the vertex would be -1, -9. Oh, this needs to be updated. Sorry. Huh. Okay, I'll need to go in and fix it. The domain and range questions are supposed to be on the next half. All right. So here we have a quadratic. Find the x-intercepts and find the vertex. So for the x-intercepts, we just factor two numbers that multiply to be 5 and add to be -6. -1 and -5. So the x-intercepts are 1 and 5. And for the vertex, we do -b over 2a. So 6 over 2 is 3. That is the x portion. Plug that in, and I get 9 minus 18 plus 5. That's 9 minus 18 is -9 plus 5 is -4. You guys good with those? Okay, that one's not supposed to be there. Okay. Does this quadratic have a minimum or a maximum? It's basically asking, does it open up? Is it happy? Or does it open down because it's sad? Opens up. How do you tell? The leading coefficient is positive. Okay. So where does the maximum value occur? It wants to know what is the x coordinate of the maximum, or the minimum in this case. So -b over 2a, that would be 4 over 2 times 2 is 1. So the x portion of the minimum is 1. And then it asks, how low does the graph reach? Well, we just plug in 1. So 2 times 1 squared minus 4 times 1 minus 2. That's 2 minus 4 minus 2 is -5. Now here's a question. What if I didn't like this equation? Can I just divide everything by 2? Yes, if, well, it is in this case. So will dividing by 2 change the shape of the graph? Is 2x squared minus 4 minus 2 any different than x squared minus 2x minus 1? Yes. The original graph is twice as tall. So when are you allowed to divide and when are you not? Well, dividing by 2 will change the shape of the graph. It will change the maximum, it will change the minimum. The only thing that will remain unchanged are the x-intercepts. So if this graph looked like that, dividing by 2 would make it look like this. Everything except the x-intercepts will be changed. So the only time you're allowed to divide by 2 is when you're finding the roots. So don't divide this by 2. Even though you can, everything's divisible by 2. But that will change the maximum and the minimum unless it lies on the x-axis. All right. We want to make X-ray machines, and the cost of each machine is given by this equation, which is the number of machines produced. So the graph is going to look something like this. If you only build one X-ray machine, it's going to cost, so one machine, it's going to cost you a lot of money because you need lots of equipment to build this. So just building one is not going to make you very much money. You have to buy the parts, you have to buy the equipment to build it. But if you make 2 machines, then the second one will be a lot cheaper, right? Because you already have all the equipment, all you need is more supplies. Well, at some point, as you build more and more machines, we reach a value that represents the smallest cost per machine. But if you start making more machines than that, the machines are going to get more expensive. Why might that be? Wouldn't you think that the more machines you make, the cheaper the machines become? You think of a reason why the price might go up after a while? Oh, yeah. You're going to have to fix your equipment, and that's more expensive. Okay, that's one. Do you think of another reason? No. So supply and demand would say the well, I guess maybe it could be. Yeah, maybe if there's a short, but this isn't how much they cost to purchase. This is how much they cost to build. So I guess it could be. Maybe you bought all the cheap parts that were available. If you want more, like if you need 500 light bulbs for your X-ray machine, then you get a certain price because you found them for cheap. But so maybe it could be supply and demand. Maybe you'd have to pay overtime to somebody to stay late to work extra machines, or maybe you run out of space in your building and you got to build a bit bigger building to make more parts. So there are a lot of reasons why the price might go up after a while. So we want to find how many machines will it take to so that the minimum price, we find the minimum price per machine. So we use that formula, 192 over 2 times 0.4. So 192 divided by 0.8 is 240 machines. So apparently for this project, 240 machines is the magic number. If you build less than that, the price goes up. If you build more than that, the price goes up. So what is the price per machine at that point? Plug that number in. So 0.4 times 240 squared minus 192 times 240 plus 29,184, and I get $6,144. So that point right there is 240, 6144. How much does one machine cost? Yeah, how much would the first machine cost if you only built one? We don't really know, but we know about what it would be. No. So this is not the total cost of all the machines. That's if you build 240, each one is 6144. So how much would one machine cost? So it's really close to this, right? 0 machines apparently cost 29,184 because that is the y-intercept. Okay, so the cost of all of the equipment to make the machine apparently is $29,000. So the first one is essentially going to be $29,000. It'll be a little bit smaller than that because we'd have to come over here to 1 and find that point. But if you only build one, you're looking at $29,000. But if you build 240, then each one only costs $6,000. If you can sell them, great. That's the goal, right? All right, last one. Nope, this one goes on the other assignment. Okay, so there are 4 or 5 problems on there that I need to take off. I thought I did that, but apparently I didn't. And I'll get that fixed. Okay, get to work.